All right, so thanks everybody for coming. The topic or the purpose of this particular advisory committee meeting is to look at education and outreach within our watershed, and whether that's with the local schools and engaging students, or whether that's with community members that live along streams. You know, from our water quality standpoint, the Watershed Council, one of our strong points is being able to engage with private landowners and kind of get them on board with various water quality issues. And so we want to be able to link into that side of things and help support the work that the jurisdictions are doing to help with temperature and mercury and all those other E. coli, all those other things. And so one of the things that I'd like us to look at is, you know, first we're going to look at the high school and how their programs are evolving to incorporate the greenhouse and the work with the Watershed Council, looking at how we can continue to support them and provide some additional educational opportunities, whether that's looking at tree canopy assessment for water quality and temperature, whether that's looking at, you know, getting students out there to help plant. We've got the South Scappoose Reach F that's going to be hopefully permitted and installed at some point in the next year. And so I know we've had LSEP, the Estuary Partnership has been really instrumental in helping us get like Otto Peterson students out there and getting their hands in the soil and some native plants in the ground. So what I'd like to do is just have a conversation around what could that look like for us? How can we support the programs that you guys are working on and trying to get some more community engagement. You know, Dave, with the tree canopy assessment that you guys have the PSU student doing right now, I can see there's ways that we could engage the high school students to, you know, continue some of that, either monitoring or identifying additional areas where that the tree canopy would be a benefit. So with that, Amanda, if you are ready, do you want to talk a little bit about what how long you've been involved with the Watershed Council and how your students are engaging and how you're building curriculum around the greenhouse environment?
Sure. I just started a class this year, plant science. It's a year-long class that students get science credit for. And it started with there's a little bit of dabbling last year. I know that I think I went out to the greenhouse a few times, but in this case, it was a more scheduled regimen, and that we're out there 3 days a week, helping with propagation and replanting things. I would like to get more involved on the ground with projects out, you know, seeing where all these plants that we're actually growing, where they're going, and hopefully look at. I haven't done any curriculum with the plant ecology as far as, you know, where we're going with that. We've pretty much done plant ID. The kids just did a seed germination lab that they'll be doing their final presentations on, which includes posters or whatnot. So that's something we can share. Might have them hang them up in the greenhouse or something, just for to share what they've done. I wanted them to focus on more the propagation of what we were doing out there, but they kind of took it into having more fun with it, like seeing how pH affects certain plant species. So it wasn't necessarily native plants, but I have a class going to have 2 sections next year. So I'll have 40 kids every day, 2 hours a day available to do work with the greenhouse. So I have to really up my ante on like, if you guys got work out there, I've got the hands to help. And we've also looked at plant pathology was one of the in classroom projects that they did. Because we didn't really know what was out there, we just did general, but I think it'd be nice to have more of a list that they could could research versus what they might see out there versus, you know, some pathology that wouldn't necessarily, you know, like tobacco plants, we're not going to deal with those. So, but there's a lot of room for growth. I'm also have an idea in next year, creating a demo native garden out in between the C Hall and B Hall on the school campus, and then also somehow incorporate some boxes for kids to use for experiments and whatever they want to use those for. So I'm hoping to grow the program and that it's allowing them to take a little bit more curiosity in their growing something to see based on what they're seeing in the greenhouse, what, you know, where else could they put that information and from what they're learning in there. But I think I love the idea of also doing some, oh, actually, and then this spring, I'm doing, it's called Greenhouse School. So we have a May J term that is a intense class for 4 weeks. And so we are going to be not necessarily using the greenhouse, but I wanted to somehow incorporate, we're actually going to be the high school kids are going to be teaching Otto Peterson kids for a little, like less than an hour, but part of it would be a greenhouse tour to show the K-3 what, you know, what we have here, because they have their garden that they started last year. We've helped a little bit with that, but they haven't really asked us to get hands-on with their, it's more of a vegetable garden that they have on their campus. So, but that's something we're hoping to get more involved with too, since I need to keep these kids busy. Otherwise they'll get in trouble. But I think water quality, when you mentioned that, Nicole, I thought that was like, oh, I'd really like to get out and because I think that's important for them to be more involved with the community, like seeing what's available or more or less what the situation is around their own community as well. Since we don't really have a local, we haven't done any monitoring. And so I think monitoring some of the sites too, I'd love to set up, try to monitor to see, so they can see what these projects, you know, the before and the after. So if there's a photo monitoring to see like, oh, look what we've done over the years. I think that would be good for them to get involved with it as well.
Yeah, setting up some photo points.
Mm-hmm.
I think also what can be really interesting and fun for the students is looking at temperature differential. We get some of those heat guns out there and point them at things, and like, you know, on a hot sunny day, what's the temperature underneath the tree? What's the temperature underneath the bench? What's the temperature out in the middle of the bus yard?
Yeah.
What does the parking lot look like? How hot are the cars? What would that look like if you had a tree canopy over that parking lot?
Yeah.
And running some of those assessments. And then that could also extend over to like for photo points, looking at how the tree canopy along South Scappoose Creek changes over time, because between Otto Peterson and various community groups, Dave's got a pretty nice canopy that's going to be developing over the next few years. The trees are 3 foot tall right now, but in a few years, they're going to be 10 feet and then 15 feet, and then they're going to start to actually create some shade. What does that do for the water temperature right there at Veterans Park? So I'm hoping that Sarah or Andrea could kind of chip in and talk about what are some other, maybe some science kinds of things that they could do for monitoring on an annual basis, rather than something that they need to be out there every, you know, few weeks or once a week doing something that's kind of an easy thing for a busy high school teacher to take on. That would also be meaningful to their education, as well as what we're trying to do for long-term data.
I will just say that I feel like there's a lot of opportunities in, you know, I'm trying to think. Milton Creek runs through a park. We have some of the worst water quality at that park. You know, that could be kind of an educational touchstone in terms of like going in there and looking at the riparian area and looking thinking about how the entire watershed may influence the water quality that we see at that point, things like that. In terms of like developing curriculum around that, I definitely feel like that would need to fit Amanda's schedule and what she likes to pull out of the work. I was going to say that I will share, I actually did create a bunch of high school curriculum during my my work on my dissertation as part of my national fellowship program. I can send that to you, Amanda. I did a bunch with seed germination and riparian area. It was just kind of this huge module. I taught for a couple years at the high school in Gresham, one of the Gresham high schools. Anyway, I can send that to you. And I feel like it could probably fit in with some of the stuff you were already talking about. In terms of water quality though, I don't know what resources you have on hand in terms of monitoring, you know, with the kids, getting them out there and looking at water quality. They have a lot of like, I know high schools sometimes that have access to like the water quality kits. Even, you know, within a term or course, it could be interesting to go out and take a couple different samples.
Yeah, our kits are pretty outdated. I know I have some, but I'm sure all of the reactants are probably
I mean, and sometimes it doesn't need to be that complicated, right? Like
dissolved oxygen.
yeah, I mean, you could just do turbidity and you could even
Yeah.
fake it with water. I mean, like that kind of stuff. You guys do that kind of stuff in your class?
We don't do it in class, but it's something, I mean, I have done it in the past. I taught environmental ed for 10 years before I got in the classroom. So I've done some stuff with that before. So
Yeah, and I mean, if you wanted to collect, you definitely could collect even like real water samples throughout the watershed if you want and show them how it varies from, you know, up in the upper watershed to the lower. I would say that, you know, it's a good teachable moment because the water quality does vary that much, but in turbidity, you could probably see the difference, you know, if you went to one of those upper, and you could also, you know, fake it a little if you wanted to. I mean, you know how it goes.
Yeah.
I'm not trying to say, but it would be representative of like real data. And then we have these this dashboard online that kids could explore the data, you know, that could be kind of an interlinking, because I know everybody likes to get online these days, and I can, maybe I'll just get your email and I can send you some resources that could be helpful.
Thank you.
But I bet Andrea has her own thoughts.
Yes, Sarah, those are great thoughts. And I've been just kind of thinking about it as you were talking. You know, Amanda, we do have, like the DEQ does have sampling equipment that you can borrow from the lab. It kind of just depends on when you need it and what you'd like to, like the kind of monitoring equipment. Like we usually have like different kinds of temperature monitors. And I'm thinking though, because most of the temperature issues are during the summer when I assume the kids aren't around, right? And I assume you're not around out there. So, because that's when all we have the temperature issues is during the summer. So that could have been, you know, really helpful.
Oh, it gets hot in September and October too.
Well, that's true. You can get some shoulder seasons and, you know, because that could be interesting, setting up like a temperature monitor or something at some of those sites to get continuous temperature, and DEQ might be able to help you out with some loggers. And I'm a little rusty on what we have at the lab, but I know we had like dissolved oxygen kits, things like that, turbidimeters to borrow. And usually they're longer term, like I'm sure you could borrow it for like the school season or something like that. Another interesting thing that I'm just thinking out loud too, and I kind of, you know, I was talking a little bit about this before, but with Nicole actually in an email, but you know, DEQ is, we have like these pollutant reduction plans that we're developing this one right now for temperature, because we know of temperature issues throughout the whole Willamette Basin and including like the Scappoose area. And one of the things that we're going to be asking people to do is looking at effective shade is what we call it. So it's shade. What is the current shade on a stream? And you can use different kind of instruments for it. Like we have a solar pathfinder that you put in the stream and it'll tell you what % effective shade. And so that could be interesting, but you kind of need it when the leaves are out. So again, you know, this, yeah, I'm looking outside right now, like you're kind of getting to a point where more leaves are out, but you would want to wait till the deciduous trees has started blooming or, leafing out, but you can also get conifers as well, though, that. So anyway, that's something that we'd be looking at because we're going to be looking at different shade gaps on these stream systems to see where we might need to have more trees planted for that effective shade that Nicole was getting at in terms of how that could impact stream temperatures. But I can give you the name of the person from our lab. His name's Nick. And see, even if it wasn't for this year right now for spring, just thinking about like next year or something about being able to get equipment.
Thank you.
Yeah.
Did you have any follow-up questions about that? We had a couple other things that showed up in the chat that I'd like to take a look at. Erin O'Connell had mentioned that dissolved oxygen testing of samples could get to pollutant levels and is pretty easy. Do we have, what does the process look like for, I've never looked at dissolved oxygen. And does that need to be processed in a lab? And is there a lab nearby, or is that something that you can do in the classroom and have that analysis right there and exactly what the pollutants are? And
There's a handheld unit you can use. That's what we do use normally, but then you can also do a titration kit, which is maybe what Andrea has handy in the DEQ office.
Well, and I also, my thought process was you could also relate that back to, because we hear about it a lot, like in the news, like algal blooms, right? Like how that whole interaction happens where if the oxygen is being consumed in the water table because of these different pollutants entering in, that like how that affects all the aquatic life in the, in the stream. And it's when I did DO testing in a lab, it's super, super simple. And I mean, you're not getting it for results necessary, but it's a pretty easy setup and feels like it could totally be something that you could do in the classroom and make as part of like this bigger discussion to relate it to these things that we actually hear about fairly regularly.
And is that something that you can do at the elementary school level too, like Otto Peterson, or is that something that you would recommend like for comprehension levels and doing more at the high school level?
Well, I mean, I'm not an educator, so I definitely think at the high school level, right, they're going to probably grasp maybe the bigger picture, but I think if you had the right teacher that understood like how the relationship works and could break it down into simpler, units or conversations, you maybe could do it for the younger kids. It just kind of depends on like what they're used to learning about and how you sort of relay it in a way that they can understand. I mean, to me, I feel like it's pretty straightforward, right? But I also went to school to be a microbiologist. So, right, like in my head, it makes sense. But for a little kid, I'm not sure, what that would look like. But they are also really smart. So I think it just depends on how you set the information up.
Sure. Greg, I see your hands raised.
Yeah. So, I've conducted 30 years of water quality monitoring across the state, and dissolved oxygen is probably one of the more difficult ones for people to do. You can do it with a meter, but the meter's accuracy depends upon the rate of diffusion across the membrane and it's really tough to calibrate accurately. The gold standard for dissolved oxygen is a Winkler titration, and that's going to give you a very accurate result because it's a straight, direct chemical measurement of the amount of dissolved oxygen. I would suggest contacting Nick Haxon, the DEQ volunteer monitoring coordinator, to see what they recommend for volunteer groups to use for dissolved oxygen right now. When I was at DEQ, the volunteer groups were using a titration kit that was supplied by DEQ. I got to tell you, I have audited literally hundreds of private consultants doing dissolved oxygen with meters who are collecting bad data. It gives you a number, but knowing whether that number is accurate or not requires a fair amount of quality assurance procedures, which I would include at least occasional cross checks with a Winkler titration.
As someone that uses the probe approach that Greg was criticizing, I mean, they do have the calibration solutions that you use, you know, before and after you go out. So I think it's just kind of whatever you have access to. I've done both methods. I think you're right in terms of like, you know, a probe is going to give you a number, whether it's calibrated or not. So you might not know if it's correct.
The problem with the meters is a lot of the procedure. I mean, I've had EPA folks come out and their meters were way off. Now this was some time ago, and I hope they've improved the technology quite a bit since I used
The
to do it.
technology has improved.
Yeah, I hope that's the case. So,
Yeah, no, it has. And you have different kinds of probes. Anyway, we don't have to have a fight about it here.
right, but I would suggest talking to Nick and find out what they recommend and go with that.
I think, you know, teaching the kids what is a realistic threshold that they would see in the water. Like, what is DO? What is a normal amount of DO that you would see in a cold water system, or if the water is, you know, heated up? And then like, that's really the most important part. So then if they are doing a titration kit, or they're doing a probe or whatever they might have, they have enough knowledge to question the data and be like, oh, it says 3 milligrams per liter. Well, does that seem right? That seems kind of low for winter DO. Maybe we should try again or test. So I think that in itself could be a really interesting and like educational like topic, right? So kind of thinking about what Greg and I are having a debate about, but like couching that and understanding the ecology and the chemistry around the dissolved oxygen in the water and what to expect.
Right. I'm saying that if you're going to use meters, you need to make sure and have a quality assurance program established that will ensure the accuracy of those readings. And I'm sure they've improved in the last 10 years.
Sweet. So Jim Brick had commented in the chat that he says, could the kids look at different aged riparian restoration sites and look at percent canopy cover, estimate the amount of solar energy put in by age of riparian stand? Jim, would you want to elaborate on that a little bit?
Sure, I'm not an educator, but I know that solar radiation plays a big role in how warm the water gets. And so having a teaching moment that looks at different, say maybe a riparian planting that was done 5 years ago, and one that was done 10 years ago, and one that was done 30 years ago, if they exist, and looking at the difference in riparian cover, and then you potentially could estimate the amount of solar exposure on that. And I don't know if you want to dive into, you know, how that affects the water temperature, but I think that would be kind of maybe some eye-opening experiences, is just seeing how slow these things take to really come to maturation, and really be able to look at maybe look at what the riparian conditions are in certain locations and have a better understanding of why the water conditions are such as the way they already are.
Yeah, so that ties into your photo points, and like taking Veterans Park and saying, okay, we've got some pretty good photo documentation at this point. Maybe there's a spot on the bridge where it's a constant spot and you know that you're on, you know, the third post over from the left, and you take your photo from there, and each year your class kind of sees what the previous years have done and how it evolves. And to Jim's point, it'd be really interesting to find a spot along the stream that has good canopy cover. And when you're maybe looking at maybe this goes in with your tree canopy assessment. One of the things that I wanted to look at using the high school for is to assess tree canopy coverage using iTree. It's an online program that you don't have to download. It's just on your browser, and you pick a study area and you drop dots in there. It brings up a dot and it asks you to determine whether it's a tree, whether it's grass, or whether it's water or a road. And then that gives you an assessment of percentage of tree canopy coverage within that study area. City of Scappoose is currently doing this for areas within their city limits. What the Watershed Council would like to do is do this within a certain distance of all of our streams. And so I could see the school, like each class working on, you know, 1 or 2 segments of a stream, and you've got 5 students that are doing the same segment, so that you've got some statistical averaging you can do. Is that one kid misses a couple trees, you know, the other 4 are going to potentially catch those trees. And you can go out and visit a section that's, you know, got good canopy coverage, and go out and visit a section that doesn't have good canopy coverage, and maybe base your assessments off of those spaces.
What was that called again, Nicole? That app? It was iTree?
Yeah, it's iTree. It was established by, I think, the USDA Forest Service and a bunch of arborists. And they've got iTree Eco, iTree Canopy. There's a whole suite of things. I'll see if I can drop a link to it into the.
Yeah, I'd be interested in seeing that.
On a site level, iTree Eco is much more powerful, but on a watershed scale or a city scale, iTree Canopy is the better one to go with. And the one thing to, like with all research, you need to have a good question to set up a framework for the data that you're putting in there. Otherwise, you go, well, I just put 4,000 dots on this map and I'm not really getting anything useful out of it. Which is what I did with I looked at our watershed, and that's when I realized, okay, we need to be looking at just within, you know, a certain buffer from the stream. So I need to get that shape file set up. And if there's anybody here that has good GIS skills and could do a 50-foot offset on the streams within our watershed, that would be really useful. We're still working on rebuilding our GIS skills at the Watershed Council. Pat was pretty proficient in it, and I used to do it a bit, but I'm 7 years since I've touched the program. To that point, I wanted to ask what a useful offset from the stream would be. Would it be like a 25-foot buffer, so you're actually getting some canopy overlap, or would you want to go out a little bit farther to 50 feet or 75 feet to kind of assess what kind of development's going on within a certain buffer from the stream?
It's a tough one, you know, Nicole. It's like, you know, DEQ is working on that right now with our total maximum daily load, and we're looking at buffers that would be protective, and we're looking like at 120-foot buffers on either side. But that might be too much for some streams, you know. It depends on the width, and there's topographic shading, and there's a lot of things that feed into shading of a stream. So, you know, I think it kind of depends on just taking a rough cut, you know, how wide the stream is. So the wider the stream, you're probably going to want to look at more of the buffer that could be providing stream shade. If it might be helpful, I can send something to you, because we developed these shade curves. So basically looking at the geographic, or I can't remember what the word is, but it's like a kind of a geomorphic area of the Willamette Basin. And you look at your stream width, if it's going north, south, east, west. And then you can look at what the effective shade should be for that stream. So it would cover the Scappoose area as well. So you'd be able to at least see what the target effective shade should be to get the shading that it needs, that, you know, based on we look at like site potential trees in the area. So looking at, you know, is it a Doug fir kind of conifer mix or something like that, or deciduous conifer mix? And then looking at that mix, it'll give you a shade quality of if it was grown, you know, 25, 30 years or so into the future, what would be the maximum % shade that could be on that stream.
That's
I have an
fascinating.
I have
go
an
ahead, Erin.
additional point on that. Sorry, if I'm interrupting. And just like another layer to add to that whole concept would actually be to look at what does development code require, right? Because there could definitely be a discrepancy between what's actually allowed in development versus what the stream really needs. And it could start to create that sort of connection in the minds of these kids that, you know, maybe our development codes, you know, need to be changed, and you know, how do we do that sort of thing? Because as of right now, yeah, maybe the stream could benefit from 100-foot buffer, but that almost basically doesn't exist when it comes to development. And so depending on if it's fish bearing, you know, you're talking 50 feet, 25 feet, that sort of thing. And so if they were, you know, able to look at not only the zoning code for the county, but also in the city of Scappoose, they could really start to look at, you know, these sort of pressures of, you know, development bumping up against the, you know, the watersheds and how that all starts to tie together.
Mhm.
Yeah, if we curated these numbers, I would love to see them as well, because we're going to be doing a GIS analysis and knowing what like DEQ is using as their kind of buffer. I mean, clearly it's going to be the question you're asking. So is it shade? Maybe, you know, Aaron, I'm thinking like, you know, how close does the house need to be to the stream for me to be thinking about the septic leaking into the river, you know, things like that. But these are all like sidebars of that information that kids could also think about. And then like what are those developmental regulations? So I'd love if you guys, Nicole, if you guys end up like kind of coming up with like a little bit of information that could be used even in, you know, whether it be in an educational setting or maybe just shared across all of us, that would be really handy. Sorry, I kind of stole, people are have their hands raised. Sorry about that.
Thank you, Sarah. That was really helpful. Dave.
Yeah, I was just going to confirm that our boundary is a 50-foot buffer, so.
Thank you. So I'd say 50-foot minimum is what we want to be looking at for our buffer. I was kind of thinking that if we had, you know, the students looking at what's the area within the 50-foot, but then they also had another shape that was the additional 100 feet beyond the 50 feet. That could also be interesting data and have that kind of separated out as two separate data sets, looking at the similar areas. Greg?
Yeah, OWEB has a water quality monitoring technical guidebook, and it has a whole chapter on shade monitoring protocols, chapter 14. It's based largely on the shade monitoring protocols that DEQ used during the development of the temperature DMDLs the first time around. So it goes into a lot of specific ways to measure shade. Densiometer is something that we used a lot, I think, in clinometer, hemispherical photography. So there's a lot of different methodologies that are pretty well spelled out there in that OWEB shade monitoring protocols guidebook.
Mm-hmm.
Nothing's changed, Greg.
Nothing's
Even
changed.
since then, same solar pathfinder and yep.
Yeah, so I think overlaying the information that Andrea talked about over our streams and figuring out, okay, well, here's how much, you know, the tree will show us where are there trees actually, and where are we not seeing shade canopy, and then we can overlay it with DEQ's information about how much shade should there be for optimal water quality, and which kind of leads me to another thing with the greenhouse class, Amanda. You guys are looking at propagating, potting things up, tree care. The BLM regularly has trees that are no longer useful to them. We just had the opportunity to take on, I think Rochelle said 10,000 trees. We didn't, I think we took 300. But that to me looks like an opportunity to get more trees out to shade our streams, but also as a potential to get them out there by way of donation, so that that money comes back to help support the Watershed Council's outreach efforts, as well as helping the high school to upgrade some of your equipment and your lab materials, so that you can be continuing to help with the monitoring and the quality of the understanding the quality of the watershed. But I think most importantly is getting the students to have an understanding of stewardship over the place that they live and why it's important.
What about seed collection? Have you guys done any seed collection with the high school students? That's one thing I was just looking. I did send Amanda the seed germination native versus non-native curriculum that I put together a while back, and it has a few species in there that are pretty common, like Juncus effusus, which is like a common rush. You find that all the time, like in a park or on the edge of somewhere wet, so an invasive, mostly invasive. And then canary grass, of course, we all know what that looks like. But then there's like common natives too, like native wetland plants, like, you know, different types of carex and bulrush that grow. You know, there's a lot of wetland in the area that you could probably just go to the edges and not even have to have like mud boots on to collect seeds. Anyway, it seems like it could be part of that.
Are those seeds ripe and ready to harvest during the school year? Or are they?
It would be, yeah, in the fall, definitely.
Okay.
And I mean, you would need to do, depending on what species you got, I mean, it'd just be like a simple Google. Some species need to be, you know, roughed up a little bit before they'll germinate, or put through some time in the freezer, you know, but that's all. It could be something that could be a whole module with a, you know. And the thing with classes, like if it's just one term, then you can't do all the different seasons of work, right? But it could be something that could, you know, seed collection could be part of that one term that's during the fall, and then, you know, roughing them up or getting them ready could be a different term. I don't know. I'm sure Amanda has different ideas, but just something I thought about, because that is bringing a lot of value back to place, right? Is going out and physically interacting with the plants and touching them and collecting those seeds, like you were mentioning, Nicole.
Mm-hmm. Yeah. I think Amanda's looking really overwhelmed right now.
Oh no, I was just saying, well,
I can't see her, so
we're following whatever the nursery's doing. So it's not that's been enough. So it's like to go out and then start a whole nother, it's like, oh, okay, well, but I think with 2 classes, we might get through the nursery stuff. You know, won't need a whole hour every day out there, so that we can focus on some of the other monitoring and water quality and stuff.
I mean,
I think
maybe the Watershed Council is out there collecting seeds and provides them to you too. I mean, that could save you a step, right? Like, you know, that could just be one thing to look at the seeds, even, you know, the native versus the non-native, and think about that stuff.
Mm-hmm.
When I think about kids and education about water quality, I think the most important thing is for them to understand the relationship between why we care about water quality. What are the impacts of having high temperatures? What are the impacts of having low dissolved oxygen? And how water quality impacts all the beneficial uses of the streams that we like to enjoy. So it's mainly about how it affects the aquatic life. So if they understand why are we concerned about this, then I think the methods for measuring that are kind of secondary to that, and something that they'll understand, why are we doing this? We're doing it because these things impact what we care about in streams. We like to have fish in our streams. Well, if the stream is too warm or doesn't have enough oxygen, the fish can't live in the stream. I will say that when working with kids, one of the things, it's a little more difficult, but the things that seem to really resonate with kids was biological monitoring, macroinvertebrate monitoring, collecting the insects that live in the streams, and then explaining to them how these mayflies and stoneflies and whatnot require good water quality. And if they've got nothing but midge larvae in there and whatnot, then that shows that you have a bad water quality. That seemed to be something they could really understand easily. And you don't even necessarily have to do a real scientific analysis. I mean, if you just do a simple kick net sample and look at that and you come up with the midges and mayflies or something, you say, we got a problem here. Or if you come up with mayflies and stoneflies and whatnot, you say, oh, it looks pretty good. It's that understanding of the relationship between temperature, oxygen, and other water quality parameters and the things that we care about, the aquatic life, and the ability to swim in the stream and the ability to drink the water.
Yeah. Well, go ahead and Dave.
So I have a silly question, but for you experts on the panel, it might be a good one. To get oxygen into the water, can you do that by just agitating it? If you could get some rapids or something that would reintroduce oxygen to that, would that be beneficial?
Yes, but the bottom line is if you have too much organic matter that's going to biodegrade in the water, that's going to take the water out. I mean, sewage treatment plants oxygenate their water to put more oxygen in there so the bugs can do a better job of eating everything that's in there. But I don't think it's a realistic solution to try to oxygenate a stream. It's really more a matter of reducing loading of biodegradable materials that are going to lower the oxygen. The other part about that is nutrients feed the algal cycle. So when algae blooms occur, you get really high levels of oxygen, but then at night when they're not respiring and producing oxygen, and you get really low levels in the morning. So you can have low dissolved oxygen because of excessive nutrients and then excessive algal bloom during the daytime, and vice versa at night.
Okay, thanks.
I wanted to just follow up here and say that I did put it in the chat, but speaking of poor Amanda, one teacher feeling overwhelmed, does this kind of tie into like a larger watershed council initiative to do more, outreach and education in general?
If we can figure out ways to fund it, yeah. I think that an informed community is a community that's going to help us, improve the water quality and improve the overall health and resilience of the watershed and the communities that live out here.
I
So,
would recommend, and I know that I feel like Marcy from the Estuary Partnership was in this group, but I haven't seen her. It might be worthy. I know that I represent the science side, and I'm sorry, we're a little bit siloed. Like the education team at the Estuary Partnership does a lot of education. They have a ton of curriculum that they've created, and I'm not part of that. So as at the Estuary Partnership, I know that you guys already are working with us, but definitely connect us to folks that you think need more of that curriculum, because I'm sure there's a ton of curriculum that we have developed around all of this that I just am not aware of because I don't work with that team directly.
yeah, and I know Marcy was invited to this meeting and had potentially replied that she was going to come, but I'm not sure. I don't see her on the call.
Yeah, Marcy and I both have small kids, and sometimes childcare after daycare hours or is challenging. So maybe we could oscillate the times a little bit. So like more during like the earlier time during the day. I know for Amanda that would be problematic. She's probably in class, but
yeah, well, and I don't know that Amanda was.
Well.
Yeah, Amanda was just here for the education talk. And so for our next one, if we want to see this happening at like 2 or 3 o'clock in the afternoon on a Wednesday, that works as well.
Yeah, it just like 4 o'clock kind of gets to like a cutoff time for a lot of folks. So just mention that. Anyway, sorry not to talk so much today, but I just think it's important to think about all these different aspects.
Well, and for going forward with the advisory council meetings, they will I'll be sending out a doodle poll about a month or a few weeks beforehand for everybody, and this time we really needed Amanda to be included in this, so it was really a little bit around when she could be here, but we wanted going forward we'll have different times on there to make sure that everybody can attend.
Yeah, and I think our next one is our next meeting is going to be in person in August, and we're going to go visit one of our projects, possibly have a potluck or have some sort of lunch provided, do kind of a, because all our meetings are largely virtual. And so I'd like to just at least once a year get us all together in the same place, go look at a project, and say hi in person. So that would be during a weekday. We'll get a few dates set out, and it'll probably be in the first 2 weeks of August. And we'll probably get that one sent out sooner rather than later, so that we can get that one on the calendar with everybody's busy schedules. So
Absolutely, I can do that, Nicole.
yeah, and I think we're really close to time. Does anybody have anything else they wanted to add to this, or that one more message in the chat? Thanks, Sarah. All right, well, I appreciate everybody joining us, and thanks, Amanda, for taking time out of your schedule. And we'll look forward to seeing everybody in August.